morning, my name is Danielle Kapowitz, and first I will be presenting on integrated math 2. This is my homework completion chart. As you can see, for the most part, I completed 100% of my homework. I slacked off on homework number 6. This is my assessment score chart. On the quizzes, I did well. I got 100%, but on the tests, I seem to have lost the knowledge. I didn't study enough, and I didn't do the corrections either. This semester, to keep my grade constant, I asked for help from my teachers and my peers. I, for the most part, completed my corrections, and I came into office hours after school with Miss Casillas. I couldn't find any of my tests or quizzes for part 1 for Essential Skill 1, so I had to change to Essential Skill 2, and I did Learning Target 2.1. It was classifying triangles. There were many vocabulary terms that we were supposed to learn for this learning target. Like, there were 2 sections, glossary review. Triangle ABC is the definition for that is all 3 angles, sums equals 180 degrees. They have 2 acute angles and 3 vertices and 3 sides. Vertices is the point where the 2 lines meet, so A, B, and C. Sides, you would write them as A, B, or AC. And angles, say we want to write angle A, we have to write angle B, A, C, where the angle we want is in the middle. The second category was classifying by angles. So an acute triangle has 3 acute angles, and an acute angle is an angle that is under the measure of 90 degrees. Equal angular triangle have 3 congruent acute angles, and congruent means equal. Obtuse triangle has 1 obtuse angle, and an obtuse angle is over 90 degrees but under 180 degrees. And a right triangle has 1 angle that has an angle of 90 degrees. I had a little problem where I couldn't find my quiz for Essential Skill 2 either, so I'm going to show you this test and my corrections, as well as another learning target with the test and the corrections. So this is problem 1 on learning target 2.1 test part 1 triangles. I got this answer incorrect because I put isosceles originally because they had 2 that were equal. But after moving on and solving these 2, I should have gone back and proved that this was scalene instead of isosceles, but I did not. I did the corrections on the page there. The next essential skill I did was 2.3, but learning target was 2.3. There was more vocabulary for this one. An equilateral triangle has 3 congruent sides. Corollary 2.3a is a triangle that is an equilateral triangle. Is only an equilateral triangle. I can't. No. If it has 3 equal sides, it means that it has 3 equal angles as well. And then the corollary 2.3b is the opposite of that. If it has 3 congruent angles, it means that all 3 sides are also congruent. An isosceles triangle has 2 congruent sides, and isosceles triangle theorem is if two sides of a triangle are congruent, then the angles opposite of the two sides are also congruent. The converse of an isosceles is if two angles of a triangle are congruent, then the sides opposite the angles are also congruent. This is the question I got incorrect for this learning target. I was confused because I thought, oh, vertical angles, and did math incorrectly. I couldn't follow my own work. So on a separate sheet of paper, I did corrections here for each question that I got incorrect. So B I got incorrect, and over here I corrected the math and the terms and the justification for each question. My semester summary. I believe I deserve the grade that I have right now because I have done a majority of the work that is required, but not all of it. And as shown before, I have expressed a slight understanding of the content, but not a full understanding. My current grade is a B+, and I believe I deserve it. I will now present the definition. I will present on Unit 1, gases, so learning targets 1A through 1E. 1A, the vocabulary we needed was volume, temperature, pressure, and the units for each of these. Volume was liters and meters, temperature was Celsius and Kelvin, but we mostly used only Kelvin, and for pressure was atmospheres, torr, and mmHg. Since we had to use Kelvin, we weren't always given it, so we learned the conversion calculations. To convert from Celsius to Kelvin, you have to add 273 degrees. To convert from Kelvin to degrees Celsius, you have to subtract 273. We also needed to know relationships between the pressure, temperature, and volume. Pressure and temperature have a direct relationship. If pressure increases, temperature also increases. Pressure and volume are inverse. If pressure increases, then volume decreases, and temperature and volume have a direct relationship as well. The next learning target in this unit was 1.B, phases of matter and diffusion of gases. States of matter were gases, liquids, and solids. Differences between each were random molecular motion. There is no set pattern, and absolute zero temperatures cause a solid. Diffusion. Diffusion is when molecules intermingle because of their random molecular motion and kinetic energy. The faster the molecules move, the faster they diffuse into the air or container that they are in. You can add heat to the container or atmosphere wherever you have the molecules, and they will move faster, therefore diffusing faster. The next learning target in Unit 1 was 1.C, STP, standard temperature and pressure. Standard pressure is 1 atm equals 101.3 kPa equals 764 equals 760 mmHg equals 14.7 pounds over inches squared, which is psi. And standard temperature is 0 degrees Celsius equals 273 K. STP, however, is 22.4 liters equals 1 mole. Learning target was 1.D, the combined gas law. This is a combination of three men's laws: Boyle, Charles, and Gay-Lussac's. The result from mixing all three of theirs was P1 V1 over T1 equals P2 V2 over T2. Our most used units for these were atmospheres, torr, mmHg, liters, milliliters, centimeters cubed, and K or degrees Celsius. 1.E would be the ideal gas law, which is Pivnert, which is pressure times volume equals number of moles times gas constant times temperature. The ideal gas constants are R equals 8.31 joules over mole K, Kelvin times Kelvin equal, and then the second one is R equals 0.0821 liters atmospheres over mole K. And the third one is R equals 62.36 liters mmHg over mole K. I'll do an example of Pivnert for you on the board. So first we have to identify what our givens are. So we're given volume, we're given our temperature, but we have to convert this to K. And a pressure, we're given our pressure. And since we're given our pressure, we also know our ideal constant because it has ATM, atmospheres. So it would be 0.0821 liters atmosphere over mole K. And we have to find the moles, which is N. So to plug this in, it would be pressure, 1.5 atmospheres, times the volume, 8.56 liters, equals the N times R, 0.0821, times the temperature, which is 0 degrees Celsius, which we have to convert to 273 Kelvin. We want to get N alone to be able to solve for it, so we have to divide by all of that.
Ms. Kapowitz, you're good on this example. I can see you got it.
Okay.
And that's Danielle. This is a little thing from Lila.
Oh,
That's what she did.
okay.